Hello friends, today I want to share my experience about creating XY plot for testing prompt or any other parameter when you want to work with Stable Diffusion XL or SDXL. Okay, this is the sample. For example, at the left, right, you can see different schedulers, and at the top, you can see some different prompt. And I want to show you that what is my workflow. At first, I am using the efficient loader. Okay, it's coming from efficiency node. Again, I will share the website with you, and you can download the last version from here and extract that into the custom node. Let me show you. Okay, ComfyUI. Yes, custom nodes. Extract the folder of the efficiency node here. Okay, and after that you can access and see the efficiency node. It's very useful, and one of the things that we can do with efficiency node is making XY plot. And here you can see that, for example, on the Y, we can define any parameter, and also on the X, we can define any other parameter. These parameters could be many different things. Okay, for example, here, if you go to the efficiency node and XY plot, XY input, you can see that, for example, you can change the LoRA, you can change the clip escape, different clip escape using different VAE, using different denoising amount, or any other thing. Here I want to show you that how you can do the setup. At first, I placed my prompt in the text box because also I want to send them to another node for using the refiner. But also you can write your prompt in the box. Let me load the default efficiency node for you. You're going to the efficiency, and this is a loader. So this is the efficiency loader. And here you can write your positive prompt and your negative prompt. And I want to tell you that it is using normal clip text encoding for working with the Stable Diffusion, but it's fine, and still it can work. This is the website of the ComfyUI. Okay, it's in Japanese language. Here you can find some information about the text encode, and if you translate the website to the English, you can see that they mentioned that the clip text encode also can work with Stable Diffusion SDXL. So it is sending the prompt also to the clip G and clip L, to both of them. So it's possible to use that. And it's not perfect, but for testing and getting the plot, you can do that, because after that, for example, you can figure out that, for example, which scheduler could be better for your prompt, or any other thing I will explain to you. Okay, here you can see that I used the checkpoint of the SDXL. Let me explain the parameters for you. Here you can select your checkpoint. Okay, for example, now I have these checkpoints in my computer, and I can select them. After that, you can load the VAE, but for the SDXL, you should use the baked VAE. And if you want to adjust any clip skipping, you can increase that. If you don't know what is clip skip, I can tell you, it can ignore some of your prompts, okay, in different levels. And for example, some checkpoints are suggesting to use clip skip at number 2, for example, because at the end level it will skip some information, and in some case it can generate better result. So you have this option, but at first you should read the manual of your checkpoint, and also you should test that. Here is the LoRa loader, so you can use and load the LoRa. For SDXL, we can use this LoRa SDXL offset. It can help us to create more high contrast image, and you can write your positive and negative prompt, and after that you can define the latent size, and this is the batch size. So it's a combination of some other node, but there is a very interesting parameter here. It's dependency, and it's the golden key for us because it's going and connecting to another node, and through that it will control all of these parameters, and it can change them, and it will help us to make this kind of plots. Okay, so these are the parameters, and also you can find some information on the web page. It's very easy, just I'm trying to explain them for the beginner guys that are joining me on the YouTube. So it's all the parameters that we have for this node and nothing else, and also it can output some options, some parameters. Here we have the LoRa stake, and at this moment I didn't use that because totally I'm not using different LoRas, and I don't have any information about the LoRa stake, but I think it can help us to load many different LoRas and load them at the same time and play with the values. I think it's something like that. Okay. And what I did, for instead of writing the prompt here, I right click on the node and I use this parameter, convert positive to input and convert negative to input. Okay. And if you don't have the WAS suite, okay, if you don't have this, you can go to utility and add a primitive node and just connect the primitive to positive, make a copy and connect that to negative. So you can write your prompt here, and after that, if you make another efficiency loader, also you can connect them to that loader. So it will help you to make some global option for your prompts. Okay, so it's, let me delete them. This is my prompt, okay. Cinematic photo of a professional chef is making a cake. 4K UHD, DSLR soft lighting, and other parameter. And this is my thought because I thought it's using and it's working with both clip G and clip L. Okay, so after that I decide to write a sentence, and after writing the sentence I add these prompts for sending some meanings to the stable diffusion. It's all. And also I have some negative prompt, and also I can write them for you on description on the YouTube. Yes. Okay, here I have the efficiency loader, and this is a sampler. Okay, so at first let me create a sampler for you. You're going to the efficiency node, and this is the sampling. and you can click on the case sampler efficient. And also when you have the loader here, you can connect the model to model, positive to positive, negative to negative, latent to latent, VAE to optional VAE, and it's all. So what is the dependency? Okay, you will go to the efficiency node and this time go to XY plot and add this to your scene, XY plot. And from the efficiency loader, connect the dependency to the input of the plot. Okay, so when you are connecting the plot to the efficiency loader through dependencies, it can control the parameters and changing the parameters that we have here. Okay, so this is our grid. The first parameter is about grid spacing. And what is the grid spacing? Let me show you on the image. Okay, already you can see that there is a small amount white pixel here. Okay, so for example, if you need 20 pixel, 5 pixel, any other parameter that you want, it's talking about flipping the X and Y for creating this grid and positioning the Y in horizontally or vertically, and all other parameters could be good. And also if you set the case sampler output image to plot, then it will create this image for you. But if you set it to images, it will generate separate image and write the parameter on each image. So in this case, I prefer to use the plot. So these are the parameters that you should set on XY plot. Okay, exactly here is the same. Okay, let me open the workflow. Okay, you can see that dependency is connected to the XY plot, and I have 15 pixel distance for my grid, and it's on. After that, you have two parameters, X and Y. And this is a grid, and we have two different, as I said, X and Y. So from here, we can work with two different ways. One of them is that, okay, if you right click and go to the efficiency now, again to the XY plot and click on XY input, you can see many parameters here. For example, XY input seeds, ++ batch, step, CFG, sampler, scheduler, denoise, VAE, positive prompt, negative prompt, checkpoint, clip escape, and many other things. Also, there is one parameter here with the name of manual XY entry. Okay, and I think it's an advanced node. Okay, and you can use that later. But totally, I want to explain that to you at this moment, and after that I will go and work with some easier nodes. Okay, here is some information about the it's some information about working with manual XY entry. Okay, we have that here. This is manual XY entry. From here on the X, you can select that what parameter should be changed. Okay, for example, you can change the seed number or any other thing, but in this sample I decided to change my positive prompt. Okay, and what is the format? At first, okay, in the first token you are writing a word for finding and replacing. In my main prompt, let me change that and move it here. You can see that in my main prompt, I was focused on a chef that is making a cake. After that, this is coming to the game, okay? It's finding a cake, okay? And it's replacing that. At the first time, it is using cake. For the second time, it is using food. Third time, it's using the soup. And for the last time, it's using a chocolate. And you should separate them with semicolon. Okay, so this is the reason that here you can see, at first we can see the cake, then food, soup, and chocolate. So with this trick you can find and replace your prompt. Okay, so it will analyze all of your prompt and it will replace the text. And for example, if you have repeated this prompt 2 times or 3 times, it will replace all of them. Okay, so pay attention to that. And also, I changed my scheduler, okay, because sometimes it's very important and you should take decision that which scheduler is working better, for example, with your checkpoint. And if you check my videos, I told you before that I prefer to use the DDIM for working with SDXL. And here, if you pay attention to the fingers, okay, all the top images are DDIM and all the bottom images are generated with cars. And for example, here the fingers are good, but here we have lots of problem in fingers. Again, in the top image, the fingers are good, but in the lower image, really fingers are not good. And also about this, it's a little better, but in the down image, really it's bad about the hand. Okay, and the sampler could be make some changes for us. Okay, the scheduler. And if you're using DDIM, it can work better, but you can test that. Okay, you can make many different plots, and after that you can take the decision. Because, for example, if you change the scene or some other parameter, maybe it could be changed. So it's better to test that, and one of the best way to testing is using the plot. Okay, and yes, and for example, this time instead of changing the scheduler, okay, for example, this time we can change the sampler, or we can change the step, or we can change any other parameter. Okay, for example, about the step, let me go here, read the parameters from here. This is the syntax. Okay, step underline 1, step underline 2. Okay, so you will write a number because the steps are will be defined with some number. Okay, the steps are here. For example, at first I generated this image with 20 steps. Okay, and I can change that. For example, for the first time I want to generate the image with 20 steps, and for the second time I want to generate them with 10 steps. Okay, and normally I want to use the DDIM and DDIM uniform. So it will create 2 parameters in Y and 4 parameter in X. The X is connected to the X and the Y is connected to the Y. And finally, you have to connect the output from a script to the sampler, okay? Because the efficiency node sampler has this parameter. And also in the sampler state, you should change that to the script. So it is trying to load the parameters from the script. And now all is good. We can do a test and we can figure out that what is the difference between these prompts in two different steps. Okay, the processing is started. We have the chef that is making the cake. Again, we have that chef. And also, please mention that now I'm using a fixed seed number. It's very, very important, okay? Because if you want to compare some images, at first you should fix the seed number. After that, you can start testing. Okay, now the chef is creating, I think, he's creating some food. Now I think he's creating some soup. Yes. Again, soup. And after that, chocolate. 20 step. And 10 step. Okay, the processing is finished and we have the final result here. You can see that the only difference between these images is using different steps in processing. This image is processed after 20 steps, but this image processed only after 10 steps. And you can see every other thing is same, but when you are processing your image with some more steps, you can get better result. You can see here, yes. Because all other parameters were same. So this kind of comparison I think is very useful, and you can make sure that which one is better. Okay, now I'm going to change the sampler state to sample, okay, and I don't want use any more from the XY plot. And once you set that to the sample, the XY plot is not working. And I want to send the image to another efficiency loader for working with refiner. So let me active them. And let me do a test for you. Okay. Okay, the first image is generated with 20 steps, and after that it's coming to another sampler, and it's this time I'm using the refiner. Okay, and Also, I have connected the XY plot, and the XY plot only have one parameter connected to the X, and it's changing the denoising amount. The first one with 2, 4, 5, 6, and 7. So 5 times, totally 5 times. It's changing the denoise parameter, and we can see the result with 5 different denoising. It's still in processing. Okay, great. So when we are using denoising about 0.2, this is the result. With 0.7, the result has some more change, but I think the details are more. For example, the details on the skin, on the hand, I think some of them is better. With denoising 0.5, I think it makes some problem in this area. With denoising 0.6, the hand is very bad. Also, I can see some more problem in the face. With the denoising amount of 0.7, still I can see many problem in the hand, and I can see that eyeglasses is added to the character. So you can see that, for example, between 0.2 up to 0.4, I think would be a good value for adjusting the denoising. Okay, and again, pay attention to that. I am using the fixed seed number. Okay, so because this is my base model, okay, and it's generate an image. So if it generates an image with fixed seed number, after that it's sending the image to my sampler, and each time that I change the parameters here, the base model stay same. It's very important. But if you change the seed number, everything could be changed and you can't compare the result. Okay, it's all, and it's very easy. Let me provide some more explain to you. If you read the names here in the X plot, for example, here you can see a XY input positive prompt SR. Okay, and you can connect that to the Y. This time you can write the word that should search in your prompt, for example, the cake. Okay, and after that, for 4 times, you can replace that with some other words. Okay, and just you have to adjust the replace counts. Okay, the maximum is 4 and the minimum is 0. But if you use the manual input, you can make many different parameters. So you have 2 options. You can select the variables from here and separate them with semicolon and writing them. And also, if you want, you can, for example, this node is for adjusting the CFG. from here you are defining the number of the variables. For example, when you are defining that to 5, it will test all of these 5 different numbers. But if you set it, for example, to 2, it is only using the first and the second numbers that you set. And for example, now if I change the connection, now on the Y, it is going to change the CFG value. From the efficiency GitHub page, you can download the workflow. I think it's here. Go to the XY plot and yes, for example, this is the workflow that you can download. I will place the link. And for example, also here in this sample, you can see that it creates different sampler with different scheduler, scheduler and also sampler. And yes, this is the best way, and you can figure out that for your prompt or for the style that you're looking for, which one is better. Also, I will place this workflow in my Patreon, and if you like to support me, please join me on Patreon, and also like and subscribe my video on YouTube. Hope to see you. Bye.